50, which contains the compounds listed correctly in order of increasing boiling points. And then we have 5 choices here. Ooh, so this is like a multiple choice question. Okay, so maybe I can kind of give you some tips as to how to do ranking questions with multiple choice. Now, the first thing is that when they're talking about, increasing boiling points, just look over the compounds that they're talking to you about. Now, it seems like they're all the 4 same, they're just jumbled up in different orders. We have N2, CS2, H2O, and KCl. And they're all going to be in, the other 4 just jumbled up. Now, I notice that I have covalent compounds, but I have a metal and a nonmetal. So that's ionic. So the first thing I have to do is I have to distinguish between covalent compounds and ionic compounds in terms of boiling points. And the information is that ionic compounds, so let's say ionic compounds, the ones that have the metals and the nonmetals always have way higher boiling points than covalent compounds. So the idea here is that the ionic compound, as many as there are, I'm just going to pull this in a little bit, maybe I'll just bring this in, they should have the highest boiling points. And remember, a boiling point is always just converting a liquid. It's the temperature in which a liquid will turn into its gas. And it kind of makes sense. All of your ionic compounds, like think of table salt, right, or any type of salt, is always a solid at room temperature, right? That's all the way. That's not even a liquid. So that's why those boiling points are really, really, really high. So on the list of these, right, we're increasing in boiling point, which means that all the ones that are stated at the end have the highest boiling point. And if we just went with what we said here, the ionic compounds have way higher boiling points than covalent ones, I know that the highest boiling point one should be the ionic compounds. So I'm just going to scan for those ionic compounds. And remember, an ionic compound is a metal plus a nonmetal. And out of all of these 4, the only ionic compound is the KCl. And there's only 2 examples in which it is the highest one. All the other ones, here's the KCl in the middle, that's not going to work. KCl's in the middle, and then KCl is the lowest boiling point. I don't think so. So these 3, C, D, and E, don't work. And look, you have now down a 50-50 shot. So that's pretty impressive by just knowing one little thing. But now we just have to deal with the difference between A and B. Now, these are all covalent compounds, so there has to be a little bit more thinking. Well, for covalent compounds, the consensus here is that the higher the intermolecular forces that you have, whether it's dispersion or dipole-dipole or hydrogen bonding, the higher the intermolecular forces, the higher the boiling point. So on a list of, N2, CS2, and H2O, let's just list them out, right? N2, CS2, and H2O. Now we can draw the Lewis structure, and if you want to, pause the video if you want to see if your Lewis structure matches mine. There's tons of videos on the channel just teaching you how to draw Lewis structures with step-by-step instructions. So if you do need a little bit more guidance, that's totally okay. We got you covered back there. So if you want, pause the video and see if your Lewis structure matches mine. So for N2, this is 2 nitrogens bound by a triple bond. The CS2 has the carbon in the middle with the 2 double bonds of the sulfurs, and the sulfur has the 2 lone pairs. And then The H2O has the oxygen in the middle, surrounded by H's on both sides, with 2 lone pairs. Now, clearly, for N2, if I split this down the middle, I have 2 nitrogens. They're identical to each other, so that's nonpolar. Keep in mind that the nonpolar is the symmetry, and the polar ones are asymmetrical. Same thing with CS2. If I write down the carbon, I just have a double bond to the S, a double bond to the S. There's no lone pairs in the middle, so this would also be nonpolar. H2O, if I cut this down the middle, it may look symmetrical because I have an H and an H on one side, but the trick here is that if your central atom has at least 1 lone pair, so lone pair of electron in the middle, this is automatically polar. So this is polar. And now just know that as far as intermolecular forces, all of these would have dispersion forces because every molecule has dispersion forces. Even KCl, the ionic compound, would have dispersion. But polar molecules have more intermolecular forces than nonpolar. If you're polar, you have the dipole-dipole force. And since water has a OH bond, that's a very special bond because that's also a hydrogen bond. Your nonpolar ones do not have them. So these are more intermolecular forces. I'll just put IMFs here for intermolecular force. And the more intermolecular force, the higher the boiling point. So out of these 3, it seems that the water should have the highest boiling point out of the covalents. So that should be the next runner-up. So KCl, and then out of the 3 covalent ones, that water should be next because it has more intermolecular forces. The other one showed the water being the least, and that's not going to work. So the answer is letter A. Bravo. But yeah, I hope this helped. I love multiple choice questions. So thank you so much for viewing the video. Subscribe to the channel if you want to help us out, if you haven't already. Thank you so much for being here and being part of the community and using this channel to help you study. I'm so glad that we're able to help you guys out. We've read all your kind comments about how this channel is helping you get, crazy grades, A+, A's, A-, and I'm so glad that this channel can do that for you. Thank you so much. Just keep learning, always keep learning, keep studying hard, and I'll talk to you later. Bye-bye.